Thank you for reaching another video. Thank you if you watched the last video where we went over networking topologies and their characteristics. This video, we're going to actually do some internet protocol addressing solutions. So we're going to first go over IP addressing schemes, and that's to facilitate network communication between two devices or between devices in general, and the devices need to be allocated on an IP address, right? So two different methods can actually be used to assign an IP address to a device, whether that be a static or dynamic IP address allocation. Now, the static IP needs to be manually assigned by the network admin, whereas a dynamic IP is automatically assigned by a dynamic host configuration protocol. So what I'm going to do with PowerShell here, I'm actually going to take a look at a few things with this command here. Big right now, for private IP addresses, they're typically used for network communication on the internal network, and these IP addresses are normally on an IPv4 address and referred to as an RFC 1918 IP address. Internal or private usually aren't reachable by external devices over the internet, and these IP address ranges can be used on multiple networks, ensuring that they're not reachable through the internet. So what we have here, right, the IP address that was manually assigned to the Ethernet adapter is a private class C IP address with the correct subnet mask associated with it. So this IP address can be written in one format, and I would say /24. It just dictates what the subnet mask is and can be translated to. And that notation, let's see, where is it here? Should show here, but typically that notation where you see the / notation is referred to a classless interdomain routing. And I'll actually show a bit of a perfect example of that a bit later. But right now, let's get into the settings. All right, so let's take a look at our adapter options, and then we're going to take a look at our Internet 3. All right, let's look at the details of it. Right, and now the Internet 3 network interface is not necessarily configured with an IP address. The IP address that is associated with it is a different one, but these IP addresses are called automatic private IP addressing. And these addresses are assigned by the host if a dynamic host control protocol server is not available to allocate the IP address automatically, right? So normal internal, external communications are not possible using these IP addresses. So I'm actually going to take a look at the properties that we have here for our IPv4 properties. Now, for these, I'm actually going to use different information here. Let's see. That's good. Right, and we're going to use the preferred DNS server as this here. Actually going to okay that. Now the Ethernet 3 network adapter was configured, as I mentioned, with the static class A private IP address. Additional network adapters can be configured for redundancy or to connect to other network segments. So for that case, I'm actually going to hit yes for this. I'm actually going to hit out close for our properties here. Now, let me close that as well. Now we can actually move on to our addressing solutions for IPv4 and IPv6. The version 6 addressing scheme was developed as a successor for version 4. As more and more devices get connected to the internet, it's discovered that there would be a shortage of public version 4 IP addresses, hence the development of the version 6 IP range, right? So the key difference, at least between version 4 and version 6, is that version 4 addresses are made up of a 32-bit numerical number grouped in 4 octets, whereas the version 6 addresses are made up of 128 bit hexadecimal configuration grouped in 8 octets, right? And what we're going to do, we're going to do a few things here. So we're actually going to swivel over to DC01. I'm actually going to take a look at that PowerShell as well. So I'm going to take a look at some loopback addresses, which is while it's loading here, the loopback IP addresses use the texture functionality of the network interface card. The network traffic that's generated is sent back to the local host, right? So once we get this up and running out, here it is. All right, so let's take a look on our PowerShell, right? And we're going to take a look at ipconfig here as well. All right, perfect. And then, since everything is good here, I'm actually going to ping an IP address as well. So let's do that here. All right, let's see what we get here. Okay, all right. The stat, like I said, you received 4, no loss. All right, that's fine. So let's do this here. All right, so I'm executing these commands in Windows PowerShell to see if we can indicate that the network interface card is functioning properly, right? And that both the version 4 and version 6 IP stacks are operational. And the loopback address for version 6 was written in the shorthand notation. So just want to notice that not all 8 octets for the address may be stipulated, but colons are used for this particular one instead, right? So now we can actually use a default gateway, which is used by an internal network device to communicate externally located network devices or resources. So I'm actually going to use another command here, well, the same command I used before this one, ipconfig all, so we can actually still take a look at our default gateway, which is here. Oh, I should not read as empty. Look at this one here, ending in 250. So what the IP all command does, it displays the IP configuration for all of the network interface cards for the device. And from the results that we have here, the default gateway for the Ethernet network interface card can be seen as ending in 250. And the GUI can also be used to identify the network configuration as well. So now that we have that information, I'm going to actually exit out of here. Now we can take a look at version 4 or IP version 4 subnetting solutions. Now, as a network engineer, sometimes designing the IP address schema for the network is essential to ensure the correct IP address schema is used. So internal networks normally use in version 4 addressing schema to allocate IP addresses to the host, right? So let's actually take a look at Win10, right? So we can actually take a look at a few different implementations of this. So while it's loading here, um, so typically what we're going to go over is actually, oh, there it is. All right, so let's open up the File Explorer and take a look at our documents, right? And then we see this cheat sheet here for our subnet, right? Now on the cheat sheet document, right? What you're going to see is here, it's just converting a number to binary, right? As far as the what's everything that's on the tab. Now, in the converting a number to binary, the numbers were converted to binary to convert, which is to convert any number to binary, right? You can do a couple of different things. As an example, the number 168 would be used, and from the table, we noticed that 128 was subtracted from 168, the resulting answer being 40. Now, to convert a number to binary, the closest highest number in the table is used and subtracted from the number that is being converted. I'm not going to get too much into that, but I just wanted to touch on that since we have the table here. Now, let's actually take a look at the subnet cheat sheet, right? Let's take a look here. Now, the cheat sheet can be used by a network engineer to easily identify the correct subnet and IP configurations for a network schema. And in this particular example, the subnet 30 mask is highlighted, and this type of subnet will normally be used to connect two routers as there would not be any IP addresses available, thus securing the routers, right? So now this brings us to the end of the video when we went over internet protocol addressing solutions. We talked about addressing schemes, version 4 and version 6 addressing solutions, as well as subnetting solutions as well. This was definitely a lot of fun. Can't wait to get to the next one where we actually go over virtual network concepts, which is going to be awesome. Can't wait to see you there. See you soon. Stay curious, stay secure.